Okay, so this one also goes out by request. Just a lot of people are struggling with the chain rule, again, sort of nested within a product rule or a quotient rule, in this case, a product rule. So I'm going to highlight a few things. First function, second function. So the first thing I notice is that, y equals, the function looks like, like an f of x times a g of x, two functions times each other. So you have to use the product rule when you're taking the derivative. But perhaps there's a chain rule nested within the product rule. So let's go ahead and take a look. And the first thing I would do also, when you see radicals, a lot of people get sort of freaked out by radicals. When you see radicals in there, go ahead and translate them to rational exponent. That's going to make your life easier. So let's just take an intermediate step to rewrite this as 5 plus 2x, whole thing to the 1/2. So when you're dealing with the square root, remember that means to the 1/2 power, and if you were dealing with a cube root, that's to the 1/3 power, fourth root to the 1/4 power, etc. Okay, so phase one is let's rewrite it. Okay, and then now we're ready. So remember, this is your first function, and this is your second function. So all right then, so y prime is going to be first function times the derivative of the second. Well, what's the derivative of this lovely thing? Well, 1/2, 5 plus 2x, and then, you subtract 1 from a half, so a half minus 1 is negative a half. But then it's chain rule because it's like a composite function, so you have to take times the derivative of this inner core here. What's the derivative of 5 plus 2x? Well, just 2. Don't forget to chain rule that out. Okay, so again, we had the first function times the derivative of the second plus, now we'll take the second function, which was the 5 plus 2x to the 1/2, times the derivative of the first function. Well, luckily the derivative of 3x is just 3. Okay, now what I want to mention is, if you, and let me highlight this, maybe in a lighter color, if you arrive here, right there, if you arrive there on a test, I'm happy, but the computer might not be happy. It wants you to clean up a little bit. So let's just talk about cleaning up. Here you have a half times 2. Well, a half times 2 is 1, and 1 times 3x is 3x. So I'm just going to write this off on the side. So if we begin to clean up the first derivative a little bit, like we said, well, half times 2 is just 1, and 1 times 3x is just 3x. So we're going to have 3x, and then we'll still have our 5 plus 2x to the negative a half. And then on this side of things, style-wise, 3 is a coefficient, so you like to float that out front. So plus 3, 5 plus 2x to the positive a half. Now here's the kicker though. Let's see if I can, I'm going to hit pause as I rewrite that on the next slide. Okay, so what I did was I sort of grabbed, where we had cleaned this up and rewrote it on the next slide. Like I said, if you arrive here, I'm super happy on a test. It's just style-wise, when you check your answer in the back of the book, it might not look like that. So let's talk about, what the author does. And I had shown this in a previous podcast, but let me remind you. What the author does is basically view 5 plus 2x, since that's a repeated quantity, they view that as a GCF. But the question is, is it going to be 5 plus 2x to the negative a half or 5 plus 2x to the half that they're going to factor out as the GCF? So the lower one, the lower exponent, right, which is negative a half. And in fact, you also, in this situation, you also have a 3 in common. So what we're going to do is we're going to pull out, well, just so I don't confuse you, 3 indeed is a GCF, but I want to focus on the quantity 5 plus 2x to the negative a half. So let's just focus on pulling this whole quantity out as a GCF and factoring that out and show you how to do that. So let's pull out the 5 plus 2x to the negative a half. I'm just going to write big old brackets here and see what we'd be left with. Well, you'd be left with 3x plus 3, and then you'd have to think about a little bit, meaning 5. I kind of like to think of it like this. Negative a half plus what makes positive a half? Because you're trying to get back, if you factor out that GCF, you say, what can get me back to the original, right? So let's see if you follow me on this. It's going to be 5 plus 2x to the 1. And how do you know? Well, think about it in the land of exponents, right? You're really adding the exponents. So when you redistribute that, is it true that negative a half plus 1 makes a half? Yeah. So it's going to send you back to the original, right? So, okay. So since that's just a 1, we can clean a lot in here. You know, you've got 3x plus 3, you know, and then you've got 5 plus 2x raised to the first power, doesn't do anything to it. So you can extremely clean, right? So 3x plus, extremely clean that up. So 3x plus 15 plus 6x, all of that's, you know, going to be inside of those parentheses. And then you've got 5x, or excuse me, 5 plus 2x still out here. So you still got your 5 plus 2x to the negative a half out here, that GCF that you had pulled out. Now, if you arrive here, I'm still happy. Just got to keep cleaning. So 3x and 6x makes 9x. So you'd have 9x plus 15. Okay? So after all that, we'd have 9x plus 15. And the other set of parentheses was 5 plus 2x to the negative a half. 5 plus 2x to the negative a half. And that is your derivative written in a prettier form. So I did want to mention, when you say 5 plus 2x to the negative a half, you know, times 9x plus 15, that makes me double happy. It's nice and clean. You could easily go, and I think about, why does that make the author happy? Because if you had to take the second derivative, it'd be easy now, right? You could use a product rule. It'd be much easier to take the second derivative. On top of that, I did want to mention, you may see the final answer written like this: 9x plus 15 all over 5 plus 2x on the bottom of the fraction underneath a radical. So that's just a style thing of how they're going to, either one of these is acceptable. So either is acceptable. And again, it just, your rate 5 plus 2x to the negative a half means the same thing as 1 over 5 plus 2x to the half, and half power, you know, raising to the half power means the same thing as the square root. So just getting yourself comfortable with, you know, manipulating and morphing things from one form to another is good. Okay, good luck.